My dear students, good morning to all. I have started a new topic which is from intermediate second year, first chapter, complex numbers. According to the importance of the chapters for IIT, I am dealing. Till now, I have dealt sets, relations, functions. Now, the second importance I am giving to complex numbers. This is, you have to open our intermediate textbook, first chapter, not NCERT, intermediate textbook only, first chapter, because for once I told, for some chapters, some textbooks I prescribe, according to that you have to follow. Okay, so complex numbers, chapter 1 in the intermediate second year textbook, that everybody usually have it. Today I started the basics, fundamentals, concepts, definitions about the chapter 1 complex numbers. So I have given detailedly everything. Please follow it. Please follow it. I have detailedly read and explained it. Okay. First of all, everybody must know the intermediate level fundamentals, intermediate level subject, everybody must know. Afterwards, I will take you some higher level. I will discuss some important questions. Later, I will move to 10 years JEE main papers or IIT advanced paper questions I discuss. That is the way. First we have to learn intermediate basics. First we have to learn intermediate. So my video will be helpful for intermediate students also. They may appear for JEE or not. For intermediate also it will be helpful. For MCET also it will be helpful. For IIT JEE also helpful. For all people. Please tell your kith and kin, relatives, friends to watch this video. This is not for any price, not for any fees, like this, no. So everybody can freely watch this video, can learn the subject, can watch my lecture on the particular topic. Okay. So here, first of all, we are discussing in this video, today and tomorrow we are discussing in the intermediate level. Later, I will take you some another higher level, that is above intermediate, some questions, some logics, some important techniques, some important theoretical applications. Let us discuss. Geometrical applications will also be there. So here geometrical representations will be there in complex numbers. That is very important. That is higher level of intermediate. Today you please go through this class. Later I will take you 2 layers. The next layer is higher level to intermediate. Next layer is 10 years JEE mains papers or IIT papers we discuss. Different various questions we discuss. Okay, these are the things. So here, please, without wasting time, go through the video. For more updates, please watch the video and subscribe it. Share it, like it. It is very important. Tell your friends. Okay? Let's meet again. Okay. Go through the notes and explanation. Go through the notes and listen to my explanation. Okay. Intermediate textbook paper 2, paper 2A, chapter 1, complex numbers. I would like to give you summary. It is fundamental. Every student must be aware of. Point number 1, x square plus 1 equal to 0 has no real solution because x square plus 1 equal to 0 implies x square equals to minus 1, implies x equals to plus or minus root over minus 1. X equals to plus or minus root over minus 1, it has no real solution. It was Euler during the years 1783 that identified a root for x square plus 1 equal to 0 with the symbol I. With the symbol I. So, at first Euler, during the year 1783, before that time, nobody dared to give solution for x square plus 1 equal to 0. But Euler has given x square plus 1 equals 0 implies x square equals to minus 1. Minus 1 is taken by Euler as I square. So x square equal to I square, x equals to plus or minus I. Thus, Euler identified a root with the symbol I, and he called it imaginary number. Of course, that is why letter I, small letter I has been taken from the word imaginary. Suppose we say so. So x square plus 1 equal to 0, x square equal to minus 1. Minus 1 is considered as I square. So x square equals to I square. So x equal to plus or minus I. That plus or minus I, we can write it as 0 plus or minus I into 1. That is in the form of A plus IB. That was firstly explained by Euler during 18th century, in the 18th century. Second point, Euler called it an imaginary root and termed the numbers of the form A plus IB AB belongs to R as complex numbers. A is just we got x square, the x square equals plus or minus I, 0 plus or minus I into 1. So it is in the form of a plus ib. A is real part, b is imaginary part. But a and b separately belongs to R as complex numbers. Third point, however, we define a complex number in a more general way, an ordered pair of real numbers a comma b and study their representation, equality and some algebraic operations on the set of complex numbers given by Hamilton during 1865. So the ordered pair AB was introduced by Hamilton. Euler identified the root for x square plus 1 equal to 0. Before him, nobody found out. After finding a root for x square plus 1 equal to 0 by Euler, Hamilton studied in most general way and he explained the complex number as an ordered pair a comma b. A and b belongs to real R. There is a discussion of some concepts like conjugacy, modulus, amplitude, these discussions will be undergone of complex number. There is, point number 5, there is a geometrical representation of a complex number and introduce the orgone plane and the orgone diagram to make out the sum or difference, product and quotient of two complex numbers. Here, after some time, the ordered pair can be represented in the geometry. It is called geometrical representation of a complex number. How? Because that is like ordered pair, no? A comma b. Similarly, x comma y. The point x comma y can be represented on the plane. So we learned in earlier stage Cartesian plane. Now this plane is not called Cartesian plane. This is called orgoned plane because this is a complex number taken as ordered pair by Hamilton and representing geometrically in one plane. That plane is special plane. That special name is called orgoned plane. And the diagrams what we draw in it or on it, they are called orgone diagrams. In the orgone plane, by giving orgone diagrams, we can make out the sum, difference, product, quotient of two complex numbers. Next, point number 6. The set of complex numbers denoted by C equals to set of ordered pair A comma B such that A belongs to R, B belongs to R equals to R cross R. Point number 7. Under 7 point small number 1, equality. Z1 equals to ordered pair AB, Z2 equal to ordered pair CD, and if Z1 equal to Z2, then A equal to C, B equal to D. A equal to C, real part A, real part C, imaginary part B, imaginary part D. We have to compare real parts, we have to equate real parts, we have to equate imaginary parts. Point number small point number 2, addition and difference. Z1 plus or minus Z2 equals to ordered pair AB plus or minus ordered pair CD equals to A plus or minus C comma B plus or minus D. Multiplication. Z1 into Z2 equals to ordered pair AB into ordered pair CD equals to, this is different, AC minus BD, AD plus BC. How it comes? It's very easy. A plus IB into C plus ID. A plus IB into C plus ID. First let us take the part without I. Next let us take the part with I. Without I, how? A plus IB into C plus ID, A into C, A into C, without I. Plus IB plus ID, I into I square minus 1, I square is minus 1. First I told, Euler has taken minus 1 as I square. So this is called plus IB, this is called plus ID, so I square BD. Minus BD, this is minus BD. In this AC minus BD, this is a real part because I is missing. Next, this is A plus IB, no? And this is C plus ID, no? A plus IB, no? IB into C, IBC. I is not missing. This is ID, no? A, no? So, IAD. I is not missing. Take I common. AD plus BC. Take I common. So, I of AD plus BC. So, I is not missing. So, this is called imaginary part. So, we can say like this, AC minus BD plus I of AD plus BC. Because AD plus BC nearby I, by the side of I is there, that is why this is called imaginary part. This is real part because no I in this. So, therefore, Z1 into Z2 equals to A comma B ordered pair into C comma D equals to AC minus BD comma AD plus BC or AC minus BD plus I of AD plus BC when you are given A plus IB into C plus ID. Division of complex numbers. Division of complex numbers. Z1 by Z2. Ordered pair AB by ordered pair CD. A plus IB by C plus ID. This is Euler's. This is Hamilton form. In division, very important point you have to remember, this is complex number. In denominator, complex number should not be there. You have to make it a real number. For that, you have to take C minus ID. C minus ID, you multiply denominator, because there should not be complex number. You have to change the denominator as a real number. So for that sake, we are multiplying the denominator by C minus ID. Similarly, we can multiply C minus by C minus ID to A plus IB equals to. This is multiplication I have told before. Like that you multiply. AC plus BD plus I into BC minus AD. Here A square minus B square. C square minus I square D square. C square minus I square D square. Suppose P plus Q into P minus Q. P square minus Q square minus I square D square. What is minus I square? Plus 1. So plus D square. Minus I square is plus 1 plus D square. So anyhow, we have changed this complex number in denominator. Always, forever, whenever it comes in denominator, the complex number should be changed into real number like this. So now what we got? AC plus BD by C square plus D square, comma, BC minus AD by C square plus D square. That is given here. Z1 by Z2 equal to AC plus BD by C square plus D square, BC minus AD by C square plus D square. A2 inverse. A2 inverse everybody knows. X comma Y. What is A2 inverse of X comma Y? Minus X minus Y. A2 inverse of AB is minus A minus B. A2 inverse of 2 1 into minus 4 6 is, you multiply this one, 2 plus I into minus 4 plus 6I. Before I told no how to multiply. Like that you multiply. If you multiply minus 14 plus 8 will come. Because it is A2 inverse, we have to keep minus additionally here, because minus here minus B. So the answer is 14 comma minus 8. Multiplicative inverse. Multiplicative inverse. Multiplicative inverse of AB is A by A square plus B square minus B by A square plus B square. It is very easy. 724 multiplicative inverse. 7 by 7 square plus 24 square 625 minus 24 by 625, because the formula is A by A square plus B square minus B by A square plus B square. Another example, multiplicative inverse of sin theta plus I cos theta is sin theta by sin square theta plus cos square theta 1. So sin theta only. Minus cos theta by sin square theta plus cos square theta 1. So minus cos theta. Sin theta comma minus cos theta. That is ordered pair. In the complex number form, sin theta minus I cos theta. Because the multiplicative inverse is A by A square plus B square minus B by A square plus B square. Next. Conjugacy. Conjugacy. Let Z equals to A plus IB. Conjugate of Z is Z bar. What is Z bar? Z bar is denotation. A minus IB. If A minus IB is there, what is the conjugate of that complex number? A plus IB. So, by that we can understand the property Z plus Z bar by 2 equals to A, because Z is A plus IB, Z bar is A minus IB, plus IB minus IB cancel, 2A by 2, A, real part of Z. Z minus Z bar by 2I, A plus IB minus A plus IB, 2IB, 2IB, A cancel, no, 2IB, 2IB by 2I, B, imaginary part of Z. Next, square root of A plus IB equals to plus or minus root over A square plus B square, root over A square plus B square plus A by 2 plus I root over A square plus B square minus A by 2 if B greater than 0, plus or minus root over A square plus B square plus A by 2 minus I root over A square plus B square minus A by 2 if B less than 0. You observe here. Thereby, root I, how it has, like that only, root I, with this formula, we can write this root I equals to plus or minus 1 plus I by root 2, root over minus I equals to plus or minus 1 minus I by root 2. This is very important because as an application it comes very frequently. Root I is plus or minus 1 plus I by root 2. Root over minus I equals plus or minus 1 minus I by root 2. According to this formula, we can write this. Root over I plus IB plus root over A minus IB equals to, with this formula, if we simplify, after cancellation, plus or minus root over 2A plus 2 root A square plus B square. This also you have to observe. At the time of application, that will be needed. Next, point number 10. Modulus or absolute value of complex number. Absolute value or modulus. What is it? In ordered pair 0, 0. This is AB point A. What is the distance between 2 points? Root over A square plus B square. That is called modulus of ordered pair AB. So, distance of OA is modulus of AB or modulus of A plus IB. Hence, modulus of A plus IB equals to root over A square plus B square. Modulus Z is always greater than or equal to 0 because always positive. For all Z belongs to C. C means complex number set. Some properties on modulus. It is also very important. Property 1. Modulus Z equal to modulus Z bar. Because modulus Z means what? Modulus A plus IB means root over A square plus B square. Modulus Z bar means what? Z bar means what? A minus IB. Root over A square plus minus B whole square. So root over A square plus B square. Both are same. Subpoint. Modulus Z square equals to, we can write this as Z into Z bar. Z means A plus IB, Z bar means A minus IB. So if you multiply A square plus B square, because A square minus I square B square minus I square is plus 1, so A square plus B square, this is also A square plus B square. Mod Z is root over A square plus B square, mod Z whole square is A square plus B square. So mod z square equals to z into z bar. Third subpoint, modulus z1 z2 equals to modulus z1 into modulus z2. Modulus z1 z2 z3 so on zn. Modulus z1, modulus z2, modulus z3, modulus so on, modulus zn. We can separately write. Fourth one. Modulus re of z less than or equals to modulus z always. Fifth one. Imaginary, what is this? Again I am telling, real part of z. Real part of z means a plus ib. What is the real part of a plus ib? A. What is im of z? Imaginary part of z. B. This is A and this is B. Real part of z modulus. It means absolute value, positive value of real part of z is always less than or equal to modulus z. And the imaginary part of z, modulus of imaginary part of z is always less than or equal to modulus z. And modulus z1 plus z2 whole square equals to modulus z1 square plus modulus z2 square plus 2 re of z1 z2 bar. This is very important. Like a plus b whole square. This is not like that, but this is different. z1 square plus z2 square, modulus z1 square plus modulus z2 square plus 2 re of z1 z2 bar. Real part of the product of z1 z2 bar. Modulus z1 plus z2 whole square plus modulus z1 minus z2 whole square equals to, this is just like a plus b whole square plus a minus whole square 2 of a square plus b square, like that only. Like that only you can remember. 2 of modulus z1 square plus modulus z2 square. Eighth subpoint, modulus z1 plus z2 less than or equal to, always less than or equal to modulus z1 plus modulus z2. These are the properties. By taking one example and you can find these properties satisfied. Next, point number 11. I have given like this. So this rotated positively with the angle theta. Swept angle is theta. The theta is amplitude or argument. If you take any length, this is r, you can take. Up to this r, up to this r, up to this r from O. Any length on this. Okay. So I have taken P, OP as R. This is called R cos theta, R sin theta, because this is XY. And if you draw like this, what is cos theta? What is cos theta? X by R. What is X? R cos theta. This is X, R cos theta. What is Y? R sin theta. This can be denoted as R comma theta. This is called polar form of a point in the polar system. You see here, if P of R theta, polar coordinates in polar system. If Pxy, then x equal to r cos theta, y equal to r sin theta, r equal to root over x square plus y square, then r is modulus and angle theta is amplitude. Theta can be called as amplitude or argument. For the principal argument theta, tan theta equals to y by x, and hence theta equals to tan inverse y by x. Always you have to take tan inverse y by x as theta. Always x greater than 0. And this theta, you see, modulus amplitude form is polar form, that is r into cos theta plus I sin theta. Theta must be belong to minus pi to pi of complex number z equals to xy. The unique argument theta of z satisfying minus pi less than theta less than or equal to pi is called the principal argument of z and is denoted by arg z. This is very, very, very important. Here what is this? Theta must in between minus pi less than theta less than or equal to pi. That is called arg z. Arg z is theta. The theta must be in these limits. Minus 1 minus root 3i. I have given one example. R into cos theta plus I sin theta. R cos theta is minus 1. R sin theta is minus root 3. R equals to 2. And cos theta equals to minus 1 by 2. Sin theta equals to minus root 3 by 2. Because once I gave one formula. What is the formula? I gave no. Tan theta equal to y by x. X equal to r cos theta, y equal to r sin theta. X equal to r cos theta, y equal to r sin theta. That I have given no. So like that, x equal to r cos theta. X equal to r cos theta. R is 2. So cos theta equals to minus 1 by 2. Sin theta is minus root 3 by 2 because this is x plus iy. No. So what is x? Minus 1. Minus 1 equal to r cos theta. R cos theta means r means how much? 2. 2 cos theta. Cos theta means minus 1 by 2. Sin theta minus root 3 by 2. Amplitude theta equals to, in the third quadrant it should be minus pi plus pi by 3 equals to minus 2 pi by 3. Since third quadrant, therefore principal amplitude is minus 2 pi by 3 minus 1 minus root 3i equals to 2 of cos of minus 2 pi by 3 plus I sin of minus 2 pi by 3 can be written as 2 of cos of 2 pi by 3 minus I sin of 2 pi by 3. So minus 1 minus root 3i. This complex number can be written in the polar form 2 of cos 2 pi by 3 minus I sin 2 pi by 3. The theta amplitude or argument is 2 pi by 3 and modulus is 2. Cos theta plus I sin theta can be written very shortly, briefly as C I S cis theta. C I S cis theta denoted, and so cis of minus theta equals to 1 by cis theta. Cis of minus theta means cos theta plus I, cos theta minus I sin theta equals to 1 by cos theta plus I sin theta. Cos theta plus I sin theta equals to 1 by cos theta minus I sin theta. That also will be happening. Always in polar form. Polar form always cis theta only. Cis theta only. Cos plus I sin only. Not sin plus I cos. If it is sin plus sin theta plus I cos theta equals to, you should write not like this. You should write in polar form cos sin. So cos pi by 2 minus theta you have to change. Sin theta you have to change cos pi by 2 minus theta plus I sin of pi by 2 minus theta. Cis of pi by 2 minus theta. You have to always write in the form of cis. Always write in the form of cos plus sine, not sine plus cos. Some amplitude properties. Cis theta 1 into cis theta 2 can be written as cis of theta 1 plus theta 2. Cis theta 1 by cis theta 2 can be written as cis of theta 1 minus theta 2. These are very important properties. Cis theta 1 by cis theta 2 is cis of theta 1 minus theta 2. Cis theta 1 into cis theta 2 can be said as cis theta 1 plus theta 2. In multiplication, we add the amplitudes. In division, in quotient, we subtract amplitudes. We know already mod of Z1 Z2 equals to mod Z1 mod Z2. Previously we said this. Again I am telling this, very important. Arg Z1 into Z2, arg Z1 into Z2, arg Z1 into Z2 means what will be coming? Plus only. Because here you see into comes what is coming? Theta 1 plus theta 2. Argument means, argument or amplitude means angle. That particular angle, r into cos theta plus I sin theta, that theta, no, this angle. So here arg of Z1 into Z2 equals to arg Z1 means theta 1 plus arg Z2 theta 2 plus some n pi for all n belongs to set of minus 1, 0, 1. This is very important point. In objectives we will apply this. Arg of Z1 into Z2 equals to arg Z1 plus arg Z2. Arg Z1 means theta 1. This is plus theta 2. Arg Z1 or amplitude Z1. Both are same. Amplitude Z2. Middle plus because that is into. Plus some n pi n belongs to set of minus 1, 0, 1. Arg Z1 by Z2 equals arg Z1 minus arg Z2 because this is quotient. Minus will come plus some n pi, similar case, n belongs to set of minus 1, 0, 1. These are the things we have discussed today, and tomorrow the further discussions will be there. Okay? Hi, I hope you have completed watching my video. You have learned some subject about complex numbers. Tomorrow also I will continue the complex numbers in the intermediate level only. Afterwards, I will take you the level above the intermediate. After that is for 2 days or 3 days. Afterwards, I will lift you to another plane, higher plane, there or where we are going to learn JEE mains subject. We are going to do 10 years back questions also, we will discuss. So for more updates, for regular class watching, you have to subscribe, you have to share, you have to like, you have to view my videos regularly. Okay? I hope you will view all my videos regularly to learn the subject. Freely you can view them, you can learn the subject. Tell your kith and kin, relatives, and your friends to subscribe, share, like. Okay, view all my update videos. Thank you. Thank you very much. Thank you.